Until recently, all AI models were built for a very specific purpose. Often this was some sort of classification task, like identifying the object in an image or translating a piece of text from one language to another. These models were trained on a dataset specifically labelled for that task. For example, you might use a dataset of images labelled with objects in them, or a dataset of texts and their translations into other languages. Each specific task we wanted to build a model for would need its own dataset and its own model. Though these very specific models are still very widely used, what's happening more recently, especially in the domain of image and text, is that we're seeing the rise of generative AI and more general purpose models. These newer models are capable of doing more than one task. Large language models, like ChatGPT for example, are able to do a whole host of text-related tasks like translate between languages, summarize long texts, or answer questions without needing those very specific and targeted training datasets. We're also seeing the first widely deployed multimodal models, such as Google's Gemini, which can work with images and text, or OpenAI's latest model, GPT-4o, which can work with image and text, but also has voice input and output modes. These models open up new possibilities that didn't exist before. Many of these large and general-purpose foundation models are trained on a broad spectrum of data and can be used in diverse fields. Still, we can also think about further tuning these models for specific domains like medicine or law. For example, Google have a version of their Gemini model that's been tuned on medical data, making it more capable in medical tasks. We also see relatively specific applications emerging, like a coding assistant to help with computer programming. There are some very capable coding assistants now, which are really helping software engineers save time in their work. Beyond working with text and images, AI is used in a range of different fields. For drug discovery, for example, AI can help identify potential candidates faster and predict relevant characteristics of new molecules. In climate science, we're using AI for predicting weather, measuring changes in our world like tracking icebergs, mapping deforestation and more. Or in agriculture, forecasting crop yield, monitoring livestock health and autonomous maintenance. And beyond these, there are many, many more applications. When we think about where domains like these where AI models are used, we naturally fall into an interdisciplinary space. And this can be inspiring for many students. Creating AI models that work in a specific domain need us to combine that AI and domain-specific expertise together. This brings AI out of the theoretical domain and into real-world applications, where students can appreciate the potential impact of their work. All of these applications, whether we're talking about very specific AI models for classification in narrow tasks, very general foundational models, or somewhere in between, are great places to explore the use of AI at the edge with students. Depending on the hardware you're targeting, or the domain expertise you're bringing in, there's a huge number of possibilities for how to think about the use cases we're teaching students and inspiring them to think big about how and where AI could be used.